I've taken a moment, I've put all your questions and the screenshots of the textbook questions into the document. So let's see how we go. I may edit this video to make it shorter. I have a hunch that it's going to take a little while. But if you don't mind watching, hopefully I'll be able to get through everything. So for the first question here, you're wondering about the answer for part A, which is the length of AE. We know that AE and AB are the same, so that's a nice isosceles triangle. So I'm just drawing this line here. Maybe I'll zoom in so you can better see what I'm doing. So we know that this is going to be 10.5 meters, or at least we can assume that from the way the question is asked. So we're going to need to use some sort of trigonometry here. Let's see, what would I use? I would probably use the sine rule here. So that's 84, which means that these two together are going to add up to 96, right? Angle sum of a triangle. So each of them is going to be 48 degrees. So that means that, oh, hold on. Yeah, we can use the sine rule. So we'd say, what are we looking for? I'm going to label this for now x. So we can say x over sine 48. I probably should have written the 48 degrees in this side actually, equals 10.5 over sine 84. And so we just rearrange that. X is going to be 10.5 times sine 48 over sine 84. And so we can calculate that. Let me grab my calculator. It's under a couple things. Okay, 10.5 sine 48. Yes, my calculator's in degrees, always got to check. Divided by sine 84. Oh, 48 and 84. Reminds me of the book 1984 that was written in 1948. Okay, so I get 7.846. Do they say anything about decimal places? They don't. So I'm going to go with one decimal place. I'm going to say 7.8. So check that against what you got. Obviously units as well. We'll say meters. Yeah. So I'm guessing you had no trouble with part B. Obviously you would need to have gotten part A correct in order to get part B correct, but you probably had the right method, right? So you work out the area of the triangle using AB sine C, and then you would add on the area of the rectangle. Okay, cool. Moving onwards. So how to work out the angle in part B. So I'm gonna have to draw a diagram for this. Let's see, a car is broken down to the north of two towns. Okay, so it's not due north of both towns, because that would mean that they were lined up. Let me see if I can draw a diagram here. So here's our car, and we know that it's roughly north, right? And so we know it's 39 k's from town A and 52 k's from town B. So I'm just gonna say that that's 39 k's. So this is town A. And then if I remember correctly, that's 52 k's. So this is town B. Now, I think I've probably drawn the diagram wrong because I have a recollection that these are meant to be like due east-west. That's okay, we'll work it out. So A is due west of B, and they're 68 k's apart. So I'm just gonna draw a horizontal line, and we'll imagine that my diagram is perfect. So part B says, what is the bearing to the nearest degree of the car from town B? So if we put in a little north line here, let's see, it doesn't say what kind of bearing, like three-figure bearing or what, or like compass bearing. I'm probably gonna do a compass bearing. So we can see straight away that from town B, it's gonna be north and then some number of degrees west. So that number of degrees is going to be this number in here. So we need to find that angle. All right, let's see. How are we going to go about this? Let me think. So if we knew this angle here, we know that those two angles have to add up to 90, right? Because A is due west, and then that's a north. So if we can find the angle inside the triangle, then just subtract it from 90, that'll give us the angle outside the triangle. So the angle inside the triangle, I'm gonna use the cosine rule because we don't know any angles other than, or we don't know any angles. So we're kind of stuck with the cosine rule. We'll always start with Pythagoras theorem, c squared equals a squared plus b squared, and then we adjust it by minus 2ab cos c. So if big C is the angle inside the triangle, then little c will be the opposite side, and then a and b are the other two sides, right? Normally, by convention, we would name a side by the lowercase character of the angle opposite, but we're abandoning that because this triangle doesn't work that way. So we have to show that we understand this formula enough that we can correctly name the sides. Before I put in the values though, I'm going to rearrange all of this. So I'm going to say, probably don't want the equal sign there. I'm going to move the negative 2ab cos c to the other side and move the c to the other side because we want eventually to have that cos c be positive. So I'm going to say 2ab cos c equals a squared plus b squared minus c squared. And so c is going to be equal to cosine inverse. I'll move this in a second. I know it's behind my head. Cosine inverse of a squared plus b squared minus c squared all over 2ab. Okay, now here's the kicker. Because we're looking for that other angle, what we need to do is we need to do 90 minus this. And I always advocate putting everything in the calculator in one step. So here's what I'm going to put in my calculator. I'm going to say 90 degrees minus cosine inverse of, so a squared is 52 squared plus 68 squared minus 39 squared over 2 times 52 times 68. So putting all of that into my calculator, I get 90 degrees minus cosine inverse of, and then I'm going to need to put some brackets. All right, so my numerator is going to be 52 squared plus 68 squared minus 39 squared, and my denominator is going to be 2 times 52 times 68, and I get 55.197, whatever. I'm just going to say 55 degrees to the nearest whole number because I don't think the question specified. Yeah, okay, to the nearest degree. Okay, that's awesome. So my answer would be north 55 degrees west. Or if I was using 3-figure bearings, that would be 55 degrees west of 360 degrees, so it would be 305 degrees. From the way the question's asked, it's not clear which one they want. I think either one is fine. All right, so hopefully that's what you got as well, and we just want the bearing. Cool. All right, now question 4. I'm not sure how to start. I tried drawing a diagram, but it didn't work. That's not a good question. There's no question mark in your question. This is something that I would recommend you practice, is identifying what it is that's gone wrong or what it is you don't understand. And I know that's hard, right? Because often you don't know what you don't know. But let's have a look. Okay, so let me make this a bit smaller. A boat is sinking 1.3 k's out to sea from a marina. Its bearing is 41 degrees from the marina and 324 degrees from a rescue boat. The rescue boat is due east of the marina. So its bearing, that's a 3-figure bearing, so we're kind of northeast from the marina to the boat. Okay, so let's start with a diagram. I'm gonna have to move sort of further to the side, otherwise I'm gonna take up space I'll need for the next questions. Okay, so let me see if I can remember these details. Here's our marina. Then so if that's north, at 41 degrees, here's our boat. And then we have, what is it, a rescue boat. And the rescue boat is east of the marina, and the boat is 324 degrees from the rescue boat. So if the rescue boat is something like here, all right, so that's due east. And if that's north, then this angle here is 324 degrees. Okay, so this is what your diagram should look like, I think. Okay, so how far is the rescue boat from the sinking boat? So what's the length of that line? And then how long will it take to travel that distance if it travels at 80 k's per hour? So whatever our answer is divided by 80. So we're trying to find this length here. Let's call that x. Hold on, do we know how far out that? We know it's 1.3 kilometers here. Okay. So we've got all the relevant information now. Because we know that it's due east and there's a 41 degree angle up the top, that tells us that this is a 49 degree angle. Let's see, what else can we do? Because we know that we have 324 degrees there, we can figure out what's inside. 360 minus 324 is going to be 36 degrees. And that's got to add up to 90 with the one inside because we have like a horizontal east-west line. So 90 minus 36 is going to be 54 degrees. All right, I think that's everything we need to know to use the sine rule. So we say x over sine 49 is equal to 1.3 over sine 54, which means x is equal to 1.3 sine 49 over sine 54, which means x is, drum roll please, 1.3 times sine 49 divided by sine 54. 1.2, how precise do they want this? 2 decimal places, 1.21. So if I was traveling at 80 kilometers per hour, just divide that by 80, it will take me, now my calculator gives me this annoying decimal, right? 0.015159175. I don't care about that. What I'm gonna do is I'm gonna hit the degrees, minutes, second button, which is gonna convert it into hours, minutes, and seconds. 0 hours, 0 minutes, and 54, well, rounding it to the nearest second, 55 seconds. So that was A, and that's B. I'll be honest, I want to think about this for a second, because that seems very fast. I mean, to be fair, for a boat to go 80 kilometers an hour is very fast. Not many boats go 80 kilometers an hour. Also, that's a 1.3, and I can kind of use my intuition to see that the other side that we found is 1.2 should be shorter because we have a steeper angle to the north from the rescue boat. I'm going to go with it. I'm going to say 55 seconds. Let me know if I'm right or wrong because I don't have the answers, but you do. So how far, how far to the nearest minute? I'm glad I checked that. So let's say 1 minute. That rescue boat may be there in time to make sure that the beer doesn't sink. Okay, I was able to find the length of the shared side of the two triangles, but then got stuck. Again, where's your question? Your question implied is, how do I do all of the question? You know, aside from the thing you were able to find. I don't like that. I mean, it's not a problem. I have fun answering these, but I can guarantee you'll be better at maths if you learn to identify what you don't understand. Okay, so let's have a look. We have a flagpole and we have a guy named Ty. So here's our flagpole, and let's say Ty is standing here, and we know that the angle of elevation from Ty to the top of the flagpole is 20 degrees. All right, what else do we know? He walks 80 meters closer, and then the angle of elevation is 75 degrees. So let's say that this is 75 degrees, and he has walked 80 meters, like that. This is a right angle because we assume a flagpole stands straight up. So we want to know the height of the flagpole. You're telling me that you were able to find the line between the two triangles. In other words, you were able to find, let's call that L. I'm going to leave most of this as an exercise for you. I'm assuming you found L. Once you know L, it's very simple because you can use SOHCAHTOA, right? So with that 75 degrees, we're looking for the opposite. You know the hypotenuse, so that's sine 75 degrees equals h over L. And so h is going to be whatever you found L to be times sine 75 degrees. Definitely be aware, you will get SOHCAHTOA questions thrown in with sine rule and cosine rule questions, and it is entirely up to you to recognize there's an easy way to do it, right? You could approach this by saying, well, this one up here is going to be 15 degrees, and then you could use the cosine rule. You could do that, but you shouldn't. You should recognize SOHCAHTOA. And in fact, this pattern of a question where you have a big triangle, a right-angled triangle divided like that, this is a standard diagram. You will see other questions that call for a diagram like this, and you should know if you're looking for anything related to the right-angled triangle, so that basically means anything except for side L, or maybe this 80 meters that we've been given. Anything else you can probably use SOHCAHTOA for. So I'm going to let you finish that because I think you have what you need to do it. All right, again with the angles. What kind of question is that? All right, a triangular field ABC has sides AB is 85 meters, AC is 50 meters. Let me think about this. How am I going to draw it? B is on a bearing of 65 degrees from A. So we could have A, obviously I'm back to front, right? But so B is going to be kind of going northeast. And C is on 166, so that's going to be like southeast. Okay, so let me draw this in. So let's say A, and then we'll put B up here, and we'll put C down here. We don't know that B and C are north-south of each other. Don't stress about that. We want to find the distance between them. We don't really care about their bearing. So AB is 85 and AC is 50. 85 meters. 15 meters, and then we have 65 and 166. Okay. Get another color just so the angles are clear. So that's 65 degrees, and then this one here is 166 degrees, which means I can find the difference between them. This here, 166 minus 65, that's going to be 101 degrees. So in order to find the length of the line BC, I'm just going to use sine rule. I lied. I'm going to use the cosine rule. So C squared, A squared plus B squared minus 2AB cos C. which means C will be the square root of 85 squared plus 50 squared minus 2 times 85 times 50 times cosine of 101. Cool. Okay. Everything into the calculator in one step. Always. This is like pro level technique. Do not work things out in the middle. You'll get rounding errors. When you're checking your answer, you're going to have to check more calculations. You want it to be 1. So let's have a look. Square root of, chuck in some brackets, 85 squared plus 50 squared minus 2 times 85 times 50 times cos 101. And I get 106.52. And based on the lengths of those, like this is what I call an idiot check. We do this a lot in physics. We're like, does this sound reasonable? I think it does. 106.5 makes 106.5. Correct to the nearest meter, that's going to be approximately 107 meters. So I hope that answers the question again with the angles. A lot of these, I would say you probably want to, just replay and pause and replay and pause, draw out your own diagrams, follow through with the working. These are really good questions, and this stuff is really good practice because there's only so many types of questions you can get asked. So once you start seeing these patterns of like, oh, they've given these two angles and one is a part of the other, so I can subtract them in order to find the angle that I care about, this is really valuable experience because you're going to be able to do this in other questions you get given. Okay. This question stumped me and I was not sure how to start with finding the angles. All right, you know what I'm going to say about your question, right? So I'm going to stop repeating myself. So find the value of h correct to 1 decimal place. How do we start with finding the angles? Well, we know 65 and 54, right? And we know that this thing has to add up to 180. So 65 and 54, that's 119. So this is going to be 61 degrees. Is that true? 50 and 60 is 110. Add 60 is 170. Yes. Okay, and then parallel lines. This is corresponding to this, so this is 61 degrees, and this is corresponding to this, so this is 65 degrees. Cool. So we know all the angles. At some point, I'm sure I've answered your question of how to start with finding the angles. So we want to know the length of h correct to 1 decimal place. Let's see. Well, if we could find this length, we could just add it on to 4.1. And we can find this length using one of our sine or cosine rules. Let's see, we know what this angle is. So I'm going to do, let's call this x. So x over sine 65, right, corresponding angles, is going to be equal to 3.9 over sine 54. In other words, x equals 3.9 sine 65 over sine 54. And then, remember, we do everything in one step. So what I'm going to put in my calculator is going to be h equals 4.1 plus 3.9 sine 65 over sine 54. You might be like, oh, Lucien, that's so much writing. Why don't I just calculate this and write in what it gives me? Trust me on this. Just do one calculation in your question, because when you're checking your answers, that's going to be a lot faster. Plus, you can look at that and you can think about the logic of where that number came from. It'll just be faster. It'll be more efficient. I'm speaking from hard-won experience. All right, so 4.1 plus 3.9 times sine 65 divided by sine 54, and I get correct to 1 decimal place. Oh, I'm glad that was in frame. I get 8.5 to 1 decimal place. I had to round up from 8.46. 8.5 There are no units in this question as far as I can see, so that's our answer. Okay, I started to construct a diagram and I knew I would have to use the sine rule, but I didn't know how to use the bearings to find an angle in the triangle. Let's have a look. A motorbike and a car leave a service station at the same time. The motorbike travels on a bearing of 80 degrees. I'm just going to do a tiny diagram. So there's our service station. 80 degrees is just under 90 degrees, so it goes this way. So let's say that's the bike. The car travels at 108 degrees until the bearing of the bike from the car is 310 degrees, which means the car is like somewhere down here, and the 108 degrees bearing is going to be like that. Okay, so let me just draw in some angles in case you're confused about what I've done here. So this is 80 degrees. This is 108 degrees. And then this is 310 degrees. So we want to know how far the motorbike traveled. Oh, and we know that this is 15.7 kilometers. So we're looking for x there. All right, so sine rule or cosine rule? We're gonna have to find some more angles. This is what your question was, right? So we know that that's 108, which means what's inside here is going to be just 28, right? It's 108 minus 80. This is a great example of what I was just saying, right? Like this technique of like, oh, we have this angle and the bigger angle and we can find this other angle by subtracting them. This is exactly that. So that's 28 degrees. I know my handwriting's messy. Let's see. This bad boy in here is going to be 50 degrees. Do we know enough yet? No, we need to get that internal angle, and it's not as easy as the previous question because C is not due east of S. So what we're going to have to do is use some parallel line maths. So the north line from S and the north line from C, they're parallel. Now at the S side, we have that 108 degrees inside, which means that in here, it's going to be co-interior with that one over there. So it's going to add up to 180. So 180 minus 108 is 72. So this thing here is 72. I know this diagram's getting really crowded. And we know that we have 50 degrees just here, which means that this is 22 in here. So we have 28 and 22. I'll write 22, but it's going to be super hard to read, so I really just hope you understand how I got it. All right, now we can use the sine rule. Can we? We can use the sine rule, but we have to figure out the angle at B. But that's easy, right? 28 plus 22, 30, 50. So that's got to be 130 up there. Okay, so in this case, x over sine 22 is equal to 15.7 over sine 130, which means x is equal to 15.7 sine 22 over sine 130. Let me scroll up a little bit. Oh, I can't scroll any further. Hold on. Let me do some one-note wizardry. Just put a dot down here so it remembers how far we can go. Okay, better. Now, is that what we're asking for? Yes, it is. So we can put all that straight into the calculator. 15.7 sine 22 divided by sine 130, and I get 7.7. It's 7.67, but to one decimal place, 7.7 kilometers. X equals 7.7 kilometers, obviously including the units. Is that reasonable? So it is about half of the other length. Bearing in mind that my diagram's not especially precise, let me know if I'm wrong. That seems possible, but it really doesn't look like it in my diagram. I'd expect it to be more like 10 or 12. So let me know if I'm wrong. If I'm not wrong, then you know what to do. Have I answered your question? How do you use bearings to find an angle in the triangle? Yes, I have answered that question. Let me know if you have any further questions. What do they mean when they say subtended? So if you have a circle and you have a sector in that circle, if we say that this sector subtends 80 degrees, that basically just means that this arc length, right, corresponds to an 80-degree angle in the middle. Or in other words, that sector is 80 over 360 of the circle, right? So the word subtends, just fancy mathematical language. Basically what it's doing is saying that like that's the angle at the middle of the triangle. Let me see if I can find a question so that we can look at an example. Radius 4 centimeters and angle subtended pi. So obviously you're working with radians, but this means draw a circle, the radius is 4 centimeters, and then what if you had an angle of pi radians, right? So but it's kind of cute to use pi because so much of this looks like pies or pie charts. So basically we have this thing, we've got a radius of 4 centimeters, and we have a sector where the angle in the middle is pi. Now that's a terrible diagram because we both know well that 2 pi is the full circle. So an angle of pi is going to be 180 degrees. It's going to be half of the circle. All right, so that hopefully answers all your questions. Please let me know if you have any others, or if I got any wrong and you need any better explanations. All right, good luck with your study.